This time we've given the robot a more difficult task than the previous one. It has to follow this track which we have designed, and you can see it over here. As you can see, it has two different kinds of surfaces we've used. One is a made surface and the other one is a shiny surface. The reason we've used two kinds of surfaces is to show the difference between the two. It can detect one, but it cannot for the other. So how does it do it? As you can see over here, we fitted the same MPOS sensors we used for the obstacle avoider. This is the same thing: the light emitting diode, the optical sensor, and these connectors put onto the microcontroller board. And I've already dumped the code for the line follower robot into this. So basically what it does is, the line follower works on the same principle of reflection of light, but this time with the opposite logic. So last time we had, if some obstacle comes in front of it and the light gets reflected, then it sends signals to the microcontroller board to turn. But for this, we'll reverse the logic. As you can see, I told you before, we have made surface and a shiny black surface. So the made surface over here, it doesn't reflect light back. So when this robot follows the track and light doesn't get reflected, it sends a signal to the microcontroller to take a turn, or as according to the track as it follows, and the light emitted from the sensors doesn't get reflected from the track, and it sends a signal to the microcontroller to turn, and this is how it works. Okay, let's start. I put the switch on and I put in the track. And there it goes, smoothly following the line. Nice. Oh yeah, we have a very sharp turn over there, so let's see what it does. Beautiful turn. Stop it. Now, let me explain what happened over here. As I told you, we have these MPOS sensors over here, and as it follows the line, and the light from the sensors falls on the black mate surface. The light doesn't get reflected back, and it sends this signals to the microcontroller board to turn accordingly, according to the sensor, which doesn't sense the light. As you can see now, we have a crossover ahead, but these are basically two different kinds of surfaces. This is a shiny surface, and the straight one is a made surface. Let's see what the robot does in this kind of situation. Okay, let's stop it. So it didn't take a turn, but why so? Because as I told you before, this crossover is a shiny surface, and as shiny surfaces reflect light, and I told you that we use the opposite logic here, that as the light gets reflected, it doesn't take a turn, and when light doesn't get reflected from the black line, the sensor senses it immediately and sends signals to the robot, to the microcontroller board to take the turn. But as it's a shiny surface, it didn't have any effect on the sensors. Now let's start it again. Wow, nice turn. We have this shiny surface over here, and as you can see, and it's taking turns very nicely. We have this same situation over here. This is the shiny surface. Let me stop it. And this time too, it took the made surface. Then take the shiny one. As we're advancing, now we have a more advanced task for the robot. This, you can see here, is the touchscreen. As I told you before, this is a normal resistive touchscreen that is used in many cell phones. And this can be used to control the robot. Now I've dumped the codes for the touchscreen control robot already, which are there in my laptop, and now let's do the connections. So according to the code which I have written, connections has to be PC0123 ports which are located over here on the microcontroller board. Now I connect the touchscreen designated ports right. Yeah. No, I've done the codes already, so let's switch it on. Now, how does the touchscreen work? As we press the upper part of the touchscreen, you can see it moves forward. Now, the lower part moves backward. Now, to move the right wheel, that means to move left, we have to press the right side. And similarly, to move the left wheel so that the robot moves right, we have to press the left side. Now, let me show you the working. With the robot here, I press the upper part. It moves forward. Now, to move it backward, I press the lower part of the screen. Again forward. Now, let's take a right turn. So we'll press left. Because, as I told you, according to the program, if we press the left side of the screen, the left wheel moves. That means it'll take a right turn. And similarly, if we press the right side of the screen, it'll take, if the right wheel moves, and it'll take a left turn. These are two opposite things, so you have to remember that. And to make the robot stop, we just don't have to press anything. Just leave the screen. I just showed you how to control this robot using touchscreen. Now let's get more technical and make the video more interesting. This small thing you can see here is the accelerometer. It is like any other normal accelerometer found in other cell phone or electronic devices. It works on the change in acceleration based upon the changing the coordinate axis of the tilt. So this is connected to the robot, and when it senses the change in acceleration or the change in coordinates, which you can say, it moves the robot according to the change. So how do we connect it? First, we use the same connector wires. You can see it has 3 pins in each set, and it has total of 2 sets of pins. The upper one, the upper pin set is called the C set, and the lower one is the D set. Now, according to the program which I have written, the C set is connected to the PC5 port on the microcontroller board. As I told you before, the C sets of pins are over here. So now let's connect this. And we have the PC4 cable which is connected to the D set. Okay. Now let me get into some more technicalities of this thing. This small chip, as I told you before, is a normal accelerometer, and this thing looks pretty small, but its working is quite complicated. So it works on the principle of the angle tilt with the normal plane as well as the coordinate axis. Now let me explain what the normal plane is. The normal plane is our basic horizontal plane, which is to say it is perpendicular to the gravitational field. So, and this device also has its predefined coordinate axis, which is x, y, and z axis. So what it does is it measures the angle with one coordinate axis and also with the normal plane, and it moves the robot according to the tilt. Suppose if we assume that this is the x-axis and this is the y-axis of this predefined y-axis of this accelerometer, and we have this as the normal plane. Then if we tilt it like this, it makes some angle with the normal plane as well as with the x-axis. So this measures both the angles and senses and sends signals to the microcontroller board to move the robot forward. Now, if we want to move it towards right, so it changes its axis to y-axis and measures the angle with respect to the y-axis and the normal plane instead of the x-axis and the normal plane. But this is how it moves. Now, if we tilt it backwards, the angle with the normal plane becomes more than 180 degree. So it measures that and takes it as a negative again. Now, there's a fix to this sensor. Actually, its minimum sensitivity is plus minus 10 degrees. Actually, it has been kept deliberately. Then, why so? Because when we keep this horizontal, we cannot always give the sensor the exact values due to human errors. So it senses only if the degree tilt with the normal plane is minimum of 10 degrees. Now let's see how it works. This we keep it in normal plane first. I switch it on. Okay, this is the normal plane. So according to the program generated, the normal plane values are all 0, 0, 0. So the robot is in the stop position. Now if I tilt it forward, it moves. Now again stop. Moves. I tilt it backward, it moves back again. So what's happening is, as I told you before, it measures the tilt with the x-axis and the normal plane. And if the tilts are positive, then it moves the robot forward. And if the tilt is negative, it moves the robot backward. Going for the sideways movement, if we tilt it sideways, so what it does is, it now measures the angle with respect to the y-axis and the normal plane, and basing on the values, suppose the right is a positive y-axis and left is a negative y-axis, it decides, the microcontroller robot decides, and the robot moves like that. Now let's see, if I tilt it towards right, actually this moves only right, it doesn't go right and forward. So that was, if we need to move it right and forward, then we have to press like this, then again forward. Now this is coming back to me. Let's go for the left. So this is left. We can move it simultaneously, like for forward left or backward left. So we have to, it's not a multitasking microcontroller board, so you can do only a single task at a time. Now, if we tilt the sensor by 180 degrees, that's again the 0, 0, 0 position. But what happens is, the coordinate axis gets reversed. Now this is the same normal plane, and as I told, the coordinate axis gets reversed. Now if we tilt the sensor backwards, it moves forward, and forward, it moves backwards, and simultaneously left, right also gets reversed. So this is how it exactly works.